Today we're really going to start diving into our trig, and we're going to talk about the ratios that are associated with right triangles. So this big block of mess that you see in your notes are all of the definitions that you'll need for every single trig problem that we're doing. So a couple key things to go over. So the opposite side, the right angle, is called the hypotenuse. So remember that your right angle is always marked with a square, and we're talking about the one directly opposite it. Okay, just the same as we identify the hypotenuse when using the Pythagorean theorem. The next two things are we have to be able to identify the adjacent side and the opposite side. And those are all based off of an angle, which is commonly referred to as theta. So this little sign right there, so it's like a circle with a line through it, is called theta. You will also sometimes see it written as a fancy B like that, in which case it's called beta. But either way, it doesn't matter what Greek letter you use, it's just referring to the angle. So the angle, the side right next to it, okay, that's called adjacent, and then there's another opposite side, okay, and those letters are going to be super important when we go to define them. So your trig ratios are let theta be an acute angle in the right triangle. Sine, okay, pronounced S-I-G-H, like a road sign, okay, don't call it sin, although on your calculator, it's marked by this button here. Okay, then you have cosine, which is on your calculator marked as COS, and then you have tangent, marked on your calculator as tan. Okay, so these are your calculator symbols. And later on, I'm going to walk you through how to do this on your calculator. So sine is defined by taking the opposite number and the hypotenuse number and writing it as a ratio. Okay, so that's where we get the acronym SO, where we have sine, opposite, hypotenuse. And those are just, we call them SOHCAHTOA because those are kind of the easy way to remember which one goes with what. So then your next one is cosine, and that's identified by adjacent divided by hypotenuse. So that one's ka. Okay, cosine, adjacent, hypotenuse. Then you have TOA, which is tangent, is opposite over adjacent. So we spell that TOA. Okay, those are your three basic ratios. The next three ratios that we're going to talk about are just the reciprocals of the first set. So we have cosecant, which is the reciprocal of sine. So you'll see that it's 1 over sine. So what happens is we just flip-flop. So instead of opposite over hypotenuse, now it's hypotenuse over opposite. And that's called cosecant. This does not appear on your calculator. So I'm going to teach you how to put it in your calculator later. Then you have secant, which is the inverse of, the reciprocal of cosine. So instead of adjacent over hypotenuse, this one's hypotenuse over adjacent. And then you have cotangent. So again, you're going to flip-flop this fraction. So instead of opposite over adjacent, now it's adjacent over opposite. That seems like a whole bunch of nonsense to you right now. That's okay. Today is probably going to feel like a lot of nonsense being thrown at you, but as you do more problems, you're going to start to slowly make sense of this. This is a brand new topic. You've never seen anything like this before, so give it a chance. Okay, bear with me here. So one of the most challenging parts about trigonometry is just making sure that you're identifying these three parts, hypotenuse, opposite, and adjacent, correctly. So this next little exercise is just going to help us practice that. So we have an angle theta. So which of those side lengths would be considered the opposite side length? So what we do is we look at theta and we basically draw a line straight across. That side is known as the opposite side. The side right next to it is adjacent. Now, how did I know that it was this side and not this side? Because this side is directly opposite of the right angle. So that one is the hypotenuse. Let's practice that again. Come down here. This one, here's theta. So we've got opposite and then adjacent. Is it going to be this one or this one? Well, look at your right angle. Directly the right angle is hypotenuse, so that means this one is adjacent. I typically have to leave adjacent until the very last because the opposite and hypotenuse are a little bit easier for me to see. Personal preference though. Okay, here's theta, so I'm going to identify opposite, hypotenuse, so this one must be adjacent. This is theta, we've got opposite, hypotenuse, adjacent. Okay, now you might think that that's a little bit silly, but if you take the time and label your opposite, adjacent, and hypotenuse, it'll bring less confusion when you start putting them into actual problems. So let's go on to the next page and let's actually start using these. So, SOHCAHTOA, okay, you've got sine, so this is a set. Remember, sine is opposite over hypotenuse. Then you have cosine, which is adjacent over hypotenuse. If you'll notice, my handwriting has been so bad, my pen broke, so kind of just working with what I've got here. And then your last one is tangent, which is your opposite over adjacent. So what this is doing is just a generic exercise to again help you practice labeling the sides. So if I were to draw just a regular right triangle, here's my right angle. Let's label A, B, and C. Now remember when we did Pythagorean theorem, we said A squared plus B squared equals C squared. Now did it really matter what side A and B were? No. But did C have a very specific side? Yes. C always has to be the hypotenuse. So when you are creating a generic right triangle, you need to make sure that the right angle, which is going to be connected to the hypotenuse, is angle C. Then you can just pick an A and B. Okay, I'm going to make this one A, and I'm going to make this one B. So then when you label the sides correspond with the angles. So notice that C is directly across from each other. So that means that this B would be directly across from angle B, and then side A would be over here. So define all 6 trig ratios for angle A. So we have sine of A, cosine of A, and tangent of A. So sine of A, remember, is opposite over hypotenuse. So if this is A, the opposite of A would be side A, and then the hypotenuse will always be C. So in generic terms, it would be A over C. Cosine is adjacent over hypotenuse. So I go to angle A, and right next to it is B over C, because remember the hypotenuse is always C. And then tangent is opposite over adjacent. So angle A would be little a over little b. Now the other 3 are based off of these first 3. So the reciprocal of sine is cosecant. So the cosecant of A, all I have to do is flip-flop these 2. So that would be C over A. The secant of A is the reciprocal of cosine. So instead of B over C, now it's C over B. And then tangent of A, the reciprocal is cotangent. So instead of A over B, now it's B over A. Now, if you're like me, That is just went right over my head. I have to have numbers in order for this to make sense and not be talking about A, B's, and C's. But we wanted to start with this because some of us like to have that. These are kind of like formulas, really, that you can use. So let's put in some numbers for those of you that need that to kind of help you conceptualize. So here when it says find the value of the trig function indicated, sine of theta. So my first thing I need to do, okay, so if I were to draw little steps here, step 1 is identify the opposite, the adjacent, and the hypotenuse. Okay, so I'm going to go to my picture. If this is theta, we've got, here's my opposite side directly across from the right angle. This would be my hypotenuse side. So that means that this non-identified side over here would be my adjacent side. Okay, once I have those labeled, step 2 is to recall the trig formula or the trig setup. So what that means is, what is sine? So I might need to go back over here because I don't really know them yet. And I might need to remember, oh, sine is opposite over hypotenuse. So I come down here and I say sine is opposite over hypotenuse. Step 3 is then to substitute your values. So opposite would be this 4 root 7, and then hypotenuse would be 16. And notice how easy that was because I already took the time and labeled them as O and H before I even got started. Okay, if I didn't label them beforehand, that step right there could have been really tricky. Once I've substituted in my final step, so step 4 is to simplify as much as possible. The majority of these are going to have radicals, they're going to have decimals, so you're going to want to have a calculator on hand. If you don't have a scientific calculator at home, that's fine, go to Desmos, okay? So I'm going to write that down here, okay? If you don't have a calculator at home, go to desmos.com, okay? And it'll do it for you. So if I type that into my calculator, it's going to simplify it to root 7 over 4, which is approximately 0.66. Okay, let's do another example. Example 3 here. Okay, and if I follow my steps over here, step 1, identify the opposite, adjacent, and hypotenuse. So find theta, opposite of the right angle is the hypotenuse. So that means that this one is A over here. Okay, we don't know A. Step 2, recall the trig formula. So cosine is ca, which is adjacent over hypotenuse. Do you see a problem? Step 3, substitute values. But look here, I need the value for adjacent, but I don't have it. So how can I find that missing side of a right triangle? This is where we bring the Pythagorean theorem back. So before I can substitute, I actually have to do a little intermediate step here of the Pythagorean theorem. Okay, so which is a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So a squared is what I don't know. B squared would be 6 squared, which is 36. And c squared would be 15 squared, which is 225. Then I'm going to subtract this 36. I get a squared equals 189. Then I'm going to take the square root. So a equals 3 root 21. Now, because I know I'm going to have to put this in somewhere else, I'm actually going to leave it as that radical. Don't change it to a fraction or a decimal just yet. Okay, so now that I have A, I can actually plug it into my cosine problem. So A is now 3 root 21. H is 15. Put in your calculator. it's going to reduce to root 21 over 5, which is approximately 0.92. Okay, if you're feeling pretty good, go ahead and pause me and do problems 4 and 5. If you're not feeling super confident, that's okay. This is still brand new. Walk with me. I'm going to do 4 and 5 with you. Okay, so this one, tangent of theta. So opposite. Here's my hypotenuse, so that means this one must be adjacent. And tangent is TOA. Okay, TOA, which means opposite over adjacent. So my opposite is 15. Adjacent is 20. Simplify that, and that is 3/4. Sine. Okay. Opposite. Hypotenuse. So this one would be adjacent. So sine of theta is opposite over hypotenuse. So 3 over 5. 0.6. Could have done this one as 0.75. Don't have to. Okay, so now let's move on to 6 through 9. So 6 through 9 are the same as 2 through 5, but instead of using the sine, cosine, and tangent, which are your 3 main trig functions, these are the reciprocals. So this SEC is secant. And if we look back at our trig sheet, and we're going to be referring to this a lot, so star it, memorize it, take a picture of it on your phone so you always have it with you and you don't have to keep scrolling. Secant is the reciprocal of cosine. So cosine is a over h, so secant is h over a. So secant of theta is h over a. So now I've got opposite, hypotenuse, adjacent. So hypotenuse is 20, adjacent is 12. So if I go and simplify that, I'm going to get 1.6 repeating. Okay, number 7, cotangent. So here I've got opposite, hypotenuse, adjacent. Cotangent, okay, got to scroll back up here, check it. Cotangent is adjacent over opposite. Adjacent over opposite. So A is 5, opposite is 12. So you've got 5/12 or 0.416 repeating. Okay, your last two, this CSC, this one is called cosecant. So I've got opposite, hypotenuse, adjacent. So cosecant is the reciprocal of cosine. No, sorry, of sine. So this one is hypotenuse over opposite. So we've got hypotenuse, which is 15, over opposite, which is 9. And if I put that in my calculator, I get 1.6 repeating. Last one is another cotangent one. So very similar to number 7 here. So we've got opposite, hypotenuse, and then this one must be adjacent. So cotangent of theta is adjacent over opposite. Adjacent is 4, opposite is 3. You could leave it as 4/3, or I'd say that's 1/3, or 1.3 repeating. Okay, and that's called just finding the trig function. Okay, for the next part, part, this is calculator practice. So later, when we're actually like solving for missing sides, which is what we'll start next time, which is the whole purpose of this, is you have to be able to know how to put this in your calculator. So if you have a scientific calculator at home, you're looking for the buttons. You're looking for this button right here. This is sine, and then another button that's going to say cosine, and another button that's going to say tangent. And those are going to be your three go-to buttons. Now, if you don't have a scientific calculator at home, what I'm going to do now is switch us over to Desmos and show you how to type it in.